We're now going to look at how to do something called rationalising the denominator. If you have a fraction with a surd on the denominator, that's not considered to be a good form to leave your answer in. We try and make the denominator into a rational number, i.e. something that doesn't have a surd on it, that's just a normal whole number or something. So the operation, the way that we can do that is if you want to take a fraction and make an equivalent fraction, you can do that by multiplying the top and the bottom by the same number. So as long as I multiply the top of this fraction by something and the bottom by the same thing, then it will still be the same fraction. I won't have changed the fraction in any way. Now in this case I need to think what would make sense. What would make sense to multiply the denominator by to turn that into a normal number rather than it being a surd? And the answer is to multiply it by itself, root 2. Because root 2 times root 2 is equal to 2, which is no longer a surd, so we've then rationalised the denominator. If we're going to do that to the bottom, we must make sure that we do the exact same thing to the top to ensure it is the same fraction. If we collect that all together now, we get 3 root 2 on our numerator, and then root 2 times root 2, which is just 2 on our denominator. Let's have a look at a similar example. Question 2 here, we've got 15 root 5. So with 15 root 5 we'll do the same again. We'll look at the bottom and we'll say, right, if I multiply it by root 5, it'll turn it into a normal number. I'll therefore multiply the top by root 5 as well. What does that give me? 15 root 5 on the top and root 5 times root 5 on the bottom, which is just 5. In this case, we can see that the 15 and the 5 will actually cancel down because they're both divisible by 5. And if I do that, I get a 1 on the bottom and a 3 on the top. Overall, that gives me 3 root 5. Last one, probably the most complex type for rationalising the denominator, is if I have something where there's an addition or a subtraction on the denominator. And this time round, it's not quite so straightforward to find something to multiply that denominator by that will turn it into a rational number. Because if I multiplied, say, the bottom by root 3, sure, it would turn this number into a 3, but it would then turn this into a 2 root 3, which is still irrational, so I haven't then avoided the problem. So what we actually do is we take the exact same numbers that we have here and we switch the sign that's in the middle. So if it's a plus there, we'll change it to a minus. If it was a minus there, we'd change it to a plus. Remember, whatever I do to the bottom, I must do to the top as well. It may be useful to remind yourself that when you have items on the denominator or the numerator being added or subtracted, that they come together. There are hidden brackets around each of those terms, and you may want to actually draw those out to remind yourself that they're actually there. So if we now expand this, we're going to do 3 times 2, that's 6. 3 times minus root 3, that's minus 3 root 3. And then onto the denominator here, I'll be doing 2 times 2, that's 4. 2 times minus root 3 is minus 2 root 3. And then root 3 times 2 is 2 root 3. So I've got minus 2 root 3, add 2 root 3, that means they've cancelled out, and that's the reason why this works. We've got rid of the surd by doing that. The last part, root 3 times minus root 3, will be minus 3. What does that leave me with? 6 minus 3 root 3 on the top. On the bottom, 4 take away 3, that's just 1. So I've got 6 minus 3 root 3.